this. The first question was asking about local area network connectivity. And the question was that your company wants to purchase some network hardware to which they can plug 30 PCs in your department, and you are being asked which type of network device would be appropriate. The correct answer was the switch. Why? Because we are talking about a department, meaning a department belongs to an organization. That is the first thing we want to understand, that a department will be for an organization, and this is going to be a private network. That is why it becomes like a local area network connectivity. Another thing is that the department would be within maybe a building or a limited location. When you look at the router, we said that the router is supposed to connect different local area networks, or is supposed to connect those networks into the internet or to other networks. So it is used for what we call internet working, but not the local area connectivity. Then when we talk about a firewall is normally used for security. So it may be able to connect many devices, but it will be used basically for security purposes, in that it is able to check what is coming into your network, or the data that is coming into your network, and the data that leaves your network. Then a server definitely is not correct, because a server is the device that is able to serve other devices on the network. It contains some resources or some data that is going to be shared within the network. So the correct answer there was a switch. Then the second question is asking about you receiving a file from your friend's phone, and you're being asked, what is the phone functioning as in that transaction? So the correct answer here is a server, because it is the one which is sending that video file. A client is the device or the node on the network that is supposed to be receiving the information that is sent. So that is the difference between the two. A local area network is not correct, because a local area network is the connectivity of computers locally in a network, or a small network that doesn't go beyond 2 kilometers. Then a distributed network is also not correct, because when we are talking about distributed network, we are talking about a network that is going to share resources, whether they are computing resources or they are resources that are shared. Maybe the processing power. We are talking about resources such as the computing power, the hardware, or even the files that are being shared. Then when you are receiving that file, the next question is asking, when you are receiving that file from your friend's phone, your computer or phone is functioning as what? The correct answer is supposed to be a client. Why? Because it has requested for services from that friend's computer or phone, and it is receiving that video. So it is a client who is receiving services or resources from the server. So the correct answer is a client. The server is not correct because it is the one sending. An end host is not correct, because an end host is just any device that is on the network, but it may not be actually receiving any kind of communication. And then a network host is also not correct, because it is also similar to an end host. It is just a device on the network, and it may not be receiving or sending any data or source. Then we go to the next question, which is asking about a company that wants to purchase some network hardware to connect its separate networks together. What kind of network device is appropriate? So, like we have said, when you look at firewall, a firewall is supposed to do what? A firewall is supposed to protect A firewall is supposed to protect the network or the local area network from either some data that is coming in which might affect it, or some data that is being extracted from the local area network. So the firewall is not correct because it is used for protection purposes or for maintaining the local area network being secure. A host is also not correct. Why? A host is just any device on the network that is supposed to maybe host or store some resource or data. A local area network is also not correct because a local area network is the connectivity of devices that is small geographically, and it is used for communication among those devices as well as sharing resources. But now when we come to the router is the correct answer. Why? Because a router is supposed now to connect these small local area networks to create a big local area network, or to create the wide area network or a metropolitan area network, meaning that all these small networks have to be connected to the router. So router is the correct answer, whereby you're going to connect separate networks so that they can be able to communicate. The next question was asking about your company needs to upgrade its old network firewall that has been in use for several years, and it needs to have a more advanced features, or you need to have one that is having more advanced features. Then you're asking what kind of a firewall should that be? And so when we start looking at the options that have been given, there is a host-based firewall. This is going to be incorrect because a host-based firewall, it could be a hardware or a software, but it is within a particular host on the network. That is what it means. So any device, even your small laptop or any gadget that you are using to connect, if it has an antivirus program, most likely it will have a host-based firewall because it is normally integrated with the antivirus program, or it is part of that antivirus program. Then the next generation firewall is the correct answer. Why? Because we are talking about a more advanced firewall that has advanced features. So when we are talking about next generation firewall, it means that you are going to get a firewall that when manufacturers are designing different devices, they design them using the generation standards. The first generation, it has these features. The next generation or the second generation has a certain set of features and such and so on. So when we are talking about a next generation firewall, it means that it is a little bit advanced than the one that you are having currently. When we are talking about the next level firewall is incorrect because when you look at the different levels that we have of connectivities, that is the same way we can have different levels of firewalls. Like within a machine, we can have the host-based firewall. Then when we go to the local area network, then that is the next level firewall, which could be a hardware. When you go to the maybe the internet, there is also another level of firewall that can be set up there. So that is how we talk about them. Then the other question was asking about you need to connect two old routers together with a UTP cable. However, data is not successfully sent or received between them. What could be the problem? So we are saying that two old routers. That is something that you need to take note of. The correct answer, of course, is they are connected with a straight through cable. Initially, when we were starting the classes, we had said that there are different types of connections. Of course, we will come back to them when we are talking about the physical layer. But when you talk about the straight through cable, a straight through cable is supposed to connect two different devices. You're talking about maybe a computer and a switch and a router, or a router and a computer. Those devices are different. But if they are the same devices, you will need a crossover cable. If devices are the same, here you are trying to connect two routers, so you need to have a crossover cable. This is the one that is used to connect devices that are of the same type, maybe a computer and a computer, a router and a router, a switch and a switch. That is the crossover cable. When we are talking about the auto MDIX mode, this is the mode in a router, and this is found in modern routers. So when we are talking about old routers, then that is where the difference comes in, because modern routers are the ones that have the MDIX mode. And this MDIX mode is supposed to enable the router to sense the type of connection that is being used in a cable and then reconfigure itself to use that kind of connection. It could be maybe the termination is based on a straight through cable, and so it will auto configure itself to work with that kind of termination. So the MDIX mode, if it was being active, then it would have been the correct, it would have been used for transfer of data. So I hope that is clear. Then the next question is asking about your company wants to connect switches in two separate buildings that are about 150 meters apart. They want to spend the lowest cost. What kind of cable should they use? So when we are talking about different cables, normally the ones which are popular, we have very many, but we always have the unshielded twisted pair, the single mode fiber, the multi-mode fiber. There is also the shielded twisted pair. So mostly we use the unshielded twisted pair. And the big question is, we want to understand, yes, that number one, the UTP, it would have been the low cost, because fiber cable is expensive. So before we go to the fiber cable, we could use the UTP. But the problem with UTP is that it will only go up to 100 meters. But here we are talking about 150 meters. So that will be not sufficient to connect those two networks or those two switches. So what do we go to? Single mode is for long distances, but a bit expensive. When we come to multimode, then we can say that it is going to support distances of up to 3 kilometers. So multi-mode fiber is the one we can go with. It's a bit cheaper than single mode, and it can go up to 3 kilometers. So we use the multi-mode fiber. Single mode is more expensive, and it goes some very long distances. You could talk of hundreds of kilometers, and it is still okay. So the correct answer is multi-mode fiber. It's a bit cheap, and it can connect up to 3 kilometers, and since we are talking about 150 meters, that is why we have excluded the UTP cable. Another question here is asking that your company wants to connect two offices about 2 kilometers apart, and they want to keep the cost as low as possible. What kind of cable should they use? Again, we have come down to the connections. So these two offices are 2 kilometers apart. So when they are 2 kilometers apart, and we want to ensure that the cable which we are using is going to keep our costs as low as possible. So what do we use? UTP is already stricken out because it can only go up to 100 meters. That is the first thing we need to know. Then single mode fiber, we are saying that it can go as many kilometers as possible. So when we are talking about 2 kilometers, then we are good to go with single mode fiber because it can go as many kilometers as we can get. And then when we are talking about multimode fiber, we have said that it can only go up to 3 kilometers or distances, it doesn't support distances of up to 3 kilometers. So in order for us to avoid the aspect of attenuation or losing signal strength, then we can go with single mode fiber. And that is the correct answer. Then we have this diagram here whereby it has indications over its network interfaces, and we are asking what would happen if you connect it to an identical switch using a straight through cable. So in the small diagram, let me see if I can enlarge it. Are you able to see that? Hello? Are you able to see the diagram? Or I am speaking alone? Ah, yes, Josephine says yes. If you look at this interface, there are several things you will look at. It has the 10 stroke 100 stroke 1000 ST ports. So what does that mean? When we are talking about 10, 100, and 1000, we are saying that it has the capability to transmit. These are the data transmission rates. It has the capability to transmit at 10 megabits per second, 100 megabits per second, and 1000 megabits per second. That it means that it has that kind of transmission capabilities. When we talk about base, when you hear about base, what does it mean? It is the baseband mode of transmission. So base T, it means that we are talking about baseband transmission mode, and then it has ports from 1 to 24. So this is a 24 port switch, meaning that you can be able to connect up to 24 devices, or you can have 24 ports of communication. And then it has the auto MDIX capability. And we have said the auto MDIX capability means that this device has the capability to auto configure or to detect the kind of connection or termination of cable that is in use, and then it reconfigures itself to operate at that cable's setup. Because like we shall see when we are doing cable termination, if you are talking of a straight through cable, there is the way you are going to have the the pairs of cable inside the UTP connected or terminated. If you are talking about crossover cable, there is the way they are also terminated. So we are being asked, what would happen if you connect it to an identical switch using a straight through cable? Since it has auto MDIX, then it would operate normally. We have said straight through cable is supposed to connect two different devices. But in this case, we are connecting devices that are of the same type. That is a switch and a switch. But since they have this auto MDIX, then operation would still continue as normal. When we say that they would operate at reduced speed, that is not correct because the auto MDIX capability kicks in automatically. They wouldn't be able to communicate since this feature is in this switch, then that already is sorted. And then the last question in this quiz was asking that your company needs to connect many hand hosts to a switch that is in a wiring cabinet on the same office floor as the host. And the question is, what kind of cable should they use? So here, you want to connect many hand hosts. That is the first question. And these end hosts are being connected to the same office floor. So they are in the same physical location. What kind of cables should you use? So if they are in the same office floor, it is very safe to say that UTP cable is the best one to use because it is going to keep the cost down. Number two, it is going to ensure that you are connecting all the devices properly. Remember, when we are doing any kind of connection, it means that most hosts do not have the capability to connect to a switch via fiber optic cabling. So since we are connecting many hosts, then UTP cable will be the best option because it will cover the short distance and we will remove the aspect of trying to bring in converters. When we are using the fiber optic cable, converters will be a challenge. Many hosts or computers normally, even when we are looking at our normal laptops, they normally connect using the UTP and they have the RJ45 port. So that will be the safest bet we can use. And UTP is the most correct answer because even most switches do not have enough SFP interfaces. An SFP interface is the one which is supposed to connect now through fiber optic cable. So fiber optic cables can be used to connect the devices over long distances, but then because there are only a few ports, they can be used to connect two switches or switches and routers, and that's it. When it comes now to using them for local connectivity, UTP cables are the standard wires for connecting devices to switches. Switches will typically have many RJ45 ports for end host to connect, and the end host will have the RJ45 ports on their network interface cards. So that will be making it easy for connection. So the correct answer is UTP. The single fiber, no. The multi-mode fiber, no. And so that was it. So you can see where maybe you went wrong, and maybe if you have a question, we can be able to answer it. Are we together up to there before we move on to the next one? Any question with that?
You can share the document you're going through WhatsApp kindly.
Oh, you have not seen it. I was sharing right now.
I joined late.
Oh, it is just the quiz that the first quiz that we did, and I had released the results. Have you looked at them? Okay, so let me go to the second one, quiz 2. Are you able to see it?
Yeah, we can see it.
Okay, so in quiz 2, we are talking about, the first question was asking HTTP data that is sent from a YouTube web server is displayed via your web browser. So what kind of a transaction is that, or what kind of a transmission is that? That is what we are being asked about. Then let us go through the options that were given. Of course, the correct answer was the same layer interaction, but let us go through them. When we are talking about adjacent layer interactions, it will refer to interaction between different layers of the OSI model. Like one layer which is on top of the other will interact. If it is the application layer can communicate with the presentation layer, that will be adjacent layer interaction, because the application layer will prepare the data that needs to be transmitted, and then it passes it over to the adjacent layer, which is presentation layer, for encryption and compression. So that is what we call adjacent layer interaction, and that goes on like that. Same layer interaction, which is the correct answer, refers to the interaction between the same layer on different hosts. So adjacent layer is on the same host but different layers. But when we are talking about same layer, we are talking about interaction between the same layer. Like application layer is interacting with application layer but on different machines. That is why we are talking about uh, different hosts. So the application layer of the YouTube web server is interacting with the application layer of the web browser on your machine. That is what we are calling now the same layer interaction. When you talk about encapsulation, that is totally different, because encapsulation is the activity that takes place when data is being prepared for transmission, meaning that it is going to be added some more information for it to be transmitted. Like when we talk of that after data has been compressed and encrypted in the presentation layer, at the session layer, it will be synchronized or some synchronization takes place. But now when we get down to the transport layer, you start encapsulating that data, adding more transmission information. That is where we are going to encapsulate it with a TCP protocol. The transmission control protocol will be attached. And when you start doing that, you are encapsulating. As you go down to the network layer, you add the IP protocol. As you go down to the data link layer, you're going to have the MAC address information and contention information on the network. So encapsulation, that is what happens. And then when you reach the destination, then you do the opposite of encapsulation, where you are de-encapsulating. So these ones are totally irrelevant when it comes to the kind of transaction or communication that is taking place. Encapsulation and de-encapsulation. Because de-encapsulation is where now you are removing those in transmission information which were attached. Then we go to the next question, which was asking, what is the name given to HTTP data that has been encapsulated with three separate headers? Now, this is part of what we will be looking at today. And when we are talking about now encapsulating with three separate headers, like we have said, as data is moving from the application layer through the presentation layer to the session layer and transport layer, at the transport layer is where you are touching those other information or headers, which are enabling it to be moving across the network. The correct answer is going to be a frame. Why? Because there are already three separate headers and one trailer. So let us go through them. The correct answer is a data frame, because here we are talking about a data packet that has already reached the data link layer. When we are talking about a data being called a packet, it is in the network layer. That is the first thing that we need to understand. So at the upper layer, that is from application up to the session layer, data will just be called data. That is the first thing that we need to understand. Data will be called data. But as it gets to the fourth layer, it becomes a segment. And the fourth layer, which we are talking about, is the transport layer. So it is a segment. And here it would have one header and no trailer. Transport layer, where we are calling it a segment, that is where we are attaching the transport control protocol. That is why it has just one header, which is the TCP protocol. And it has no trailer. Then when it gets to the third layer, or the third layer, which is the network layer, then it would be called a packet. And a packet, it would have two headers and no trailer. So a packet will have the TCP protocol and it will also have the IP protocol. So TCP, like we know, is for connection orientation or ensuring that there is a connection between the sender and the receiver. And it is used for creating a circuit through which data is going to be transmitted. We shall look at that. But when it comes to the third layer, we are talking about now attaching the IP protocol. That is where you're going to have now the source IP address and destination IP address attached so that as the packet moves through the network, any device that receives the packet can be able to check who is the source and who is the destination so that they can either, if they are the destination, they will take the packet. If not, they will forward the packet towards the destination address. So a packet is at the layer 3. Then when we get to layer 2, which is the data link, that is where we have now a frame. And it is going to have 3 headers and 1 trailer. How? Because at the data link layer and the physical layer, you're going to, when we will go to the actual application, we are going to find that they are combined with the physical layer so that you can attach the MAC address. So on top of the TCP, on top of the IP, you are going also to include the MAC address. The MAC address is the machine address. And like we had looked at the OSI layer representation, then the MAC address is supposed to ensure host-to-host movement. This is a lecture which I am going to record because I am sure some of you did not attend. We did it face-to-face here. So I will record this one and share it just to show how data is broken down as it comes to the physical layer. So a data frame is going to include the 3 headers and 1 trailer. And the trailer is what we call the frame check sequence or the FCS. And the trailer is supposed now to check for errors in the data frames as they are being moved from host to host. As they move through the network, then it keeps on checking for errors and it has a checksum mechanism, which we normally call the cyclic redundancy check, CRC, which is used now to check for any error as the data moves from one host to the next. So I hope that is clear where we are talking about a data frame. So a data frame is going to have those 3 headers, which we have said that is going to have the TCP, the IP, and then the MAC address information, which is attached. And then the trailer is the FCS or the frame check sequence. Hapo tuko sawa. We move on to which layer of the OSI are the most relevant to the role of a network engineer? So, like we have said when we met in the class, We said that the OSI model can be divided into two areas. There is what we call the host part or the host section, and there is what we call the network section. Meaning that there are activities which are going to take place at the host device, or maybe if it is the sender or the receiver, the activities which will take place there, but there are others which will take place on the network as the data is being transmitted. Now, the host activities are going to be the application, presentation, and session. So the correct answer here was the transport network, data link, and physical layers. Those are the layers which are very relevant to a network engineer because these are the layers, like we have seen. That is where you start adding the protocol information. Protocols are rules which govern how devices are going to communicate. So a network engineer is supposed to understand how those rules are configured and how they are going to be working on the network so that they can be able to know how to troubleshoot any challenge and how to ensure that data is successfully transmitted or delivered. That is why we are talking about now the transport layer. You attach the TCP, the network, you attach the IP, the data link, and the physical, you attach the MAC address as well as the frame check sequence. So all of these activities are relevant to the network engineer, and this is the network section. When you talk about these three, then you are leaving the physical. The physical layer is where you will find that there are the communication standards which are being used, like the Ethernet standards, where it talks about which transmission rates, what kind of maybe signals are going to be used. If it is through the cable, we are talking about the bit signals being used or the electric current. If we are talking about wireless, we are talking about now data being transmitted in form of signal or what we call the analog waveforms. So the physical layer is also very important to tell us even which kind of cabling we are going to use, like we have seen in the previous quiz, like which cabling is right for which type of connection and so on. When you talk about network layer, yes, it is important to the network engineer, but it is not just the only. Now, there are others which we call the host activities, application, presentation, and session. They normally happen on your device before the data is released to be sent on the network. These activities, that is why in the TCP/IP model, they are combined into one. Application layer is where you're interacting with the different applications. Maybe it is on Gmail where you're trying to create your email. It is at the application layer where the user is creating the message. Then as the message is being prepared for transmission, or it is a WhatsApp where you are dealing with an application, maybe to send some photos to your friend. So at the application layer is where you're trying to attach the photos to your message, and then the presentation layer is where the photo is going to be prepared for transmission. How does it get prepared? By it being compressed. So even if you took a photo today and it is like 10 megabytes or 4 megabytes, as it is being transmitted, the receiver will get a photo of like 100 kilobytes. So where did the other 900 kilobytes go? They were compressed, or the most unnecessary parts of of that photo have been removed so that we can save on network resources, especially the bandwidth. So at the presentation layer, that is where compression is taking place, encryption is taking place, so that even if that message you are sending is intercepted, it is already encrypted and an authorized user cannot be able to see it. And then at the session layer is where you are synchronizing. We will come to see the importance of synchronizing. Maybe your device is transmitting at 100 megabits per second and the network is operating at 10 megabits per second. It means that you need maybe to step down or to do some buffering so that the transmission is not going to overwhelm the network or the receiving device. So synchronization and timing takes place there. So all of this preparation happens inside your device. It could be your laptop, it could be your mobile phone, or any other gadget that you're using for transmission. And then after that is when we come to the network area where you are dealing with now the activities of protocols and configurations. So these ones are relevant to a network engineer. These ones are relevant to maybe application developers. How is the application going to handle these activities? So I hope there we are all together. Then we go to the next question where we are asking the link layer of the TCP/IP model is equivalent to which layers of the OSI model? Link layer. Like we have just mentioned, the correct answer was supposed to be the data link and physical. So the transport and the network, it is not correct. These ones are separate. Transport layer is separate from the network layer. Network layer is also separate from data link layer. And the data link layer is usually combined with the physical layer to create the link layer. So the correct answer is data link layer and physical layer. They are combined to form the link layer. Then the other question is about which layer of the OSI model provides host-to-host or what we call end-to-end communications. So when we were looking at the OSI layers, we said that there are all those layers which are going to have end-to-end and others are going to be node-to-node. So here, the correct answer is definitely transport layer. So let us look at them. The transport layer is the one that ensures that you are going to have end-to-end communication, or an application on one end is going to communicate with another application on the other end. That is how TCP is normally used. Like I had said, that TCP protocol is supposed to initiate a circuit. That is, some resources are going to be set up so that there is a circuit that is created for that transmission to take place, and it continues to take place until it is over and that circuit is broken down. So there is always uh, the connection process and then the tear down process. Like right now, how we are communicating, maybe we are using WebEx. WebEx is going to use the TCP protocol to initiate a connection that is going to ensure that communication is taking place, which is multimedia mostly. And we normally use port addresses at the transport layer. So TCP is supposed to use port addresses for that kind of communication. So the application layer is going to provide what we call process-to-process communication. When you look at the application layer, like we have said, it is going to be maybe the HTTP protocol taking place, whereby it is one application communicating with another application, a Gmail application communicating with another Gmail application, a YouTube application communicating with another YouTube application to deliver. So it may not be real time. Transport layer, we are talking about real time transmission like we are doing now. Network layer is also it also does end-to-end communication, but it is also not real time. It just releases a packet to move from the source to the destination, but it doesn't ensure delivery. It is only transport layer which uses TCP protocol which ensures delivery and acknowledgement of that delivery. If now we lost connection, you would see a message coming to you telling that you are not able to communicate because there is no connection. Why? TCP is supposed to ensure that there is continuous connection, which is going to ensure that data packets that are transmitted are going to be received on the other end. Then the data link layer, like we say, data link layer is supposed to do host to host or node to node transmission, meaning that any transmission coming from my machine here will move from this machine to the nearby switch. So that is node-to-node transmission. So the source will be my machine, the destination will be the intermediate switch. Then from that switch, there is another transmission, the switch being the source to the other intermediate device, which could be a router. So the router becomes the destination. After that, there is the router being the source to the other intermediate node, which could be another router being the destination. And that is what we call node-to-node communication. And here we use MAC addresses. So I hope that one is clear. Then, which field of an Ethernet frame provides receiver clock synchronization? So when we are talking about receiver clock synchronization, what exactly do we mean? Like we have said, there is the synchronization uh, activity which takes place before transmission begins, so that there is always, each device is going to have its own clock or the rate at which it is sending or receiving data. So the correct answer here is going to be the preamble. Like we will see, the lecture we are doing right now will be showing the data frame or the Ethernet frame as it moves on the network. It has all these components. And so the preamble is going to be a series of ones and zeros, which should be 7 bytes. So it is going to be ones and zeros. A byte is going to be 8 bits. So if it is 8 bits and we are talking about 7 bytes, it is going to be those 8 bits times 7, which is going to give us a total size of 56 bits. That is why we are talking about 7 bytes. And it allows the receiving device to synchronize its receiver clock. So the preamble is like, it is the one which introduces this data frame. It is coming at this rate. Can you synchronize yourself to receive this frame which is coming? So that is the preamble. When we talk about the SFD, it stands for start frame delimiter. It is used to signify the end of the preamble. So as the device which is receiving the frame, after it has read the preamble, it has to be shown where the preamble ends. And normally it will be a series of ones and zeros, but at the end, it is going to be 1 1 instead of 1 0. The preamble will have 1 0 1 0 1 0 1 0, but the SFD will have 1 0 1 0 1 0 1 1, showing the end of the preamble. And then the type, this is a field that is supposed to indicate the type of packet which is encapsulated within that data frame. So the type field is supposed to show what packet is that. And then the FCS, the frame check sequence, we have said that it is used to detect errors that have occurred during the transmission. So that is how those fields are supposed to operate, but we shall look at them in detail. Then, how long is the physical address of a network device? Now, this is a question I expected everybody to get. It is 48 bits. When you talk about byte, first of all, it means that it is very huge because 8 bits create 1 byte. So that is where you need to always be careful when using either bits or bytes. So anything with a byte, put it aside, that it should not be the correct answer. It is 48 bits, meaning that it is going to have, um, what are they, 8 octets. And these octets are going to create 6 octets, which are going to be 8 bits each, so as to have 48 bits. That 2 bits are supposed to be used for the IP address, which is 4 octets of 8 bits. We are going to have that 2 bits. But where we are talking about bytes, that is already incorrect. So a physical address is always going to have 48 bits. If you talk about 48 bytes, then you will end up having 384 bits, which is too huge and it is incorrect. Then we come to the OUI. When we talk of an OUI, what does it mean? An OUI, it stands for Organizationally Unique Identifier, and normally it is the first half of the 48-bit address, which is supposed to indicate the organization that created that device. Because we have said each device is normally has a physical address, and a physical address is supposed to show the unique device that is transmitting that data at the physical layer and the data link layer. And when it is showing the unique identification of that device, it is normally like the serial number of that device. That serial number is going to be divided into two parts. So the first part, or the first 24 bits, is going to show the unique value that is assigned to the maker of that device. So for example, if we count the first um, 24 bits, they are going to be where? They are going to move up to 1, 2, 3, 4, 5, 6. So that is the first part. So the correct answer should be yes, the E8BA.70. That is the first part which is supposed to show the manufacturer of that device. Then the second part is the unique identifier of that device. If you count these bits, all of them, it will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you divide it by 2. This first part is showing the unique identifier of the maker of that device, and this other one is the unique identifier of that device. I hope that one we are correct. So the most important thing to note here is what is an OUI. And we have said that is an organizationally unique identifier. Hope we are all together up to there. Then, which field of an Ethernet frame does a switch use to populate its MAC address table? Now, like we will see, a switch always has a routing table, or it has a MAC address table. And this table is normally used to show the list of addresses or the list of devices which are attached to that switch. And whenever a new device comes in, it is also added into that MAC address table, so that whenever it receives a data frame, because a switch operates at layer 2, and at layer 2 we normally use MAC addresses. So whenever it receives a data frame and that data frame has a MAC address, then it will compare that MAC address with the list of MAC addresses on its table, so that it can use it to either forward it to the particular device on that network it is operating, or forward it to other networks. So I hope that one is clear. And so the MAC address of the field of an Ethernet frame, it is the one that is used to by the switch to populate its routing table, and it associates the source MAC address with the interface on which the frame was received. This allows the switch to learn how to reach other devices on that network. So when we are talking about the Ethernet having a MAC address, then we are talking about the source MAC address. So the router, the switch will read the source MAC address so that it can be able to associate that data frame with that particular device, which is sending the frame. So the correct answer is the source MAC address. When you look at preamble, we have already said that one is for clock synchronization. The length is normally used interchangeably with the type. the length is supposed to show the size of that data frame, then the destination MAC address definitely is where the frame is going. Then what kind of a frame does a switch flag out of its interfaces except the one it was received on? So when we talk about a switch having interfaces, we are talking about a scenario of the ports. If a 24 port switch is the one we are using, then it means that it will have 24 interfaces. So that is something I would like you to note. And so when we are talking about now a switch flooding out the frame, it means that for it to flood, it doesn't know where the switch came from or the frame came from or where it is going. In other words, it means that the switch doesn't have the particular destination address for which the frame is intended. So what does it do? It will flood it out, or it will broadcast that frame, and it will broadcast it to all the other ports except where it came in from, because that should have been the source. So it will just broadcast it. And the correct answer is the unknown unicast frame. If it is known unicast, then it means that it already knows where it should forward it to. Or it means that the destination address is already on the switch's routing table. And so it doesn't need to flood it, or it doesn't need to broadcast it. It just needs to forward it to that particular destination address. All cast, there is nothing called all cast. That is very incorrect. So we always have the non-unicast and a non-unicast. Non-unicast is where you have the destination MAC address on the switching table, and so it is easy to forward it to the particular destination address. But a non-unicast is where you don't know the destination address, so you forward that data frame or you flood that data frame through all the other ports. So if it has 24 ports, it will forward that to the other 23 ports except the one port it came in through. So I hope that one is clear. Up to there, do we have any question?
Mwalimu, these things you're teaching are somehow new to some of us. I was thinking we hold a lecture. You explain to us about all these models and how these layers work, and
Okay.
thereafter give us a makeup cut. We did this cut blank.
Oh, Pole. I know some of these things I had taught in class, so I will just start off with the OSI and then come to the TCP, and then we go to the physical layer and data link layer. So can we have like how many minutes break? Ndio tukuja tuanze na hiyo OSI so that at least everybody comes on board, because this is the theory of the most important part. I had already started on IP addressing, but then I thought I need to come back to this because kuna watu walifanyia class, wengine hawakufanyia class. How many minutes do we have? Do we take our break?